What does an alternate future for the exploited workers in Southeast Asia's electronic waste industry look like? Electronic waste, the world's fastest growing waste stream, and a key byproduct of the digital post-human age, is the main material driver for the project. Examining the starting and end points of the global e-waste stream, the project addresses the transboundary waste piling up on Thailand's shores. More often than not, the waste ends up on drowning coastal waste infrastructures. Taking refuge in the landfill, the workers acquire infrastructure required to excavate the landfill. Mining the landfill for materials, they build a wall to encircle the landfill, protecting their resources from the encroaching waters. At the heart of the project is the plasma gasification technology, a furnace that converts the unsortable landfill waste into plasma rock. The unsorted waste is fed into the plasma arc furnace, which produces slag and other metals which can be used as valuable construction materials. Another key byproduct is syngas, which can be processed into electricity to sustain energy for the project. Various infrastructures are employed to extract the waste materials from the landfill. A trommel is used to separate waste from the soil. Thereafter, the waste is processed through the plasma gasification process and stored in the silos, awaiting to be retrieved. The plasma rock is brought towards the wall to be combined with the transboundary electronic waste. On the other side of the wall, floating modules perform the job of sorting the transboundary e-waste dumped by foreign countries. These modules intercept the waste material and sorts them into their recycled constituents. Along the wall, a host of machinery combines the sorted e-waste with the plasma rock. Speculating on a new building material, the plasma rock can be mixed with lightweight composites to produce lightweight concrete. These materials are casted along the wall in a productive belt, to be used for the construction of habitation modules in the later stages of the project. The project attempts to develop hybridized infrastructures based on the plasma arc furnace. The system accounts for the inputs and outputs of the furnace process, and combines food systems with energy systems in an integrated process. Taking advantage of the gravitational logic of waste chutes, the crane hoists the modules into a hybridized tower. The waste is fed into the furnaces via differentiated waste chutes, and produces syngas to be fed into the turbines and heat exchanger at the top of the tower. A network of different chutes transport the waste material, slag and water through the tower. Double lift cores service the towers, allowing for efficient access. At the top of the tower, desalination plant enables a clean water supply to the aeroponics system in the tower. Throughout the tower, the furnaces are stacked in a parallel configuration, enabling maximum utility. Staggering floor plates provide access to the maintenance area and the habitation decks. Aeroponic systems proliferate throughout the tower, taking advantage of the clean water from the desalination plant. The automated harvesting system is trawled by the robotic arms in a circular manner. Sky bridges connect the tower core to the habitation modules. Syngas output by the furnaces accumulate at the top of the tower, awaiting to be converted into energy for desalination and electricity. Complexity is achieved by utilizing a common discrete component adhering to a set of rules and connective logic. A simple geometry with a mereology that allows for different spatial and temporal logics to proliferate the habitation zone was selected. The basic unit is made from a recycled steel wire frame and later infilled with the lightweight concrete slabs to allow for a time-based and responsive aggregation. Each habitation pods can house 2 persons. The habitation zone is made from a kit of discrete components. enabling a dynamic circulation throughout the living zone. The discrete components rest on a megastructure that spans between the furnace towers and are aggregated with a set of rules that prioritize circulation and flexibility. The corridors are aggregated first to ensure continuous circulation throughout the level, followed by the habitation pods. Stairs enable three-dimensional circulation and opens more possibilities for other connections. To adapt to the rising water levels and to ensure sustenance, a regenerative aquaculture system is adopted. Taking into account the livelihoods of the existing farmers, the aquaculture system is designed to allow the main livestocks of oyster, seaweed and shrimps to thrive under the new aquatic territory. Over time, higher levels of technological adoption allow for increasing automation in the productive systems, emancipating the workers from labor. The aquaculture system grows into a zone for leisure activities to occur. The project invites us into deeper forms of speculation of an accelerating world, in a future where technological progress can overtake some aspects of laborious work. To project the exploited workers into emancipated individuals, New Operaism seeks to redefine autonomy in the form of social activities in a post-labor society. Various social activities are speculated in the form of future, common, spaces, situated above the habitation deck. Reimagining 5 key areas of health, food, e-commerce, manufacturing and sports, in a future scenario of technological progression. The vulnerable and overexploited community occupy their new aquatic territory by processing the landfill and transboundary electronic waste into building materials, aquaculture and energy systems, augmenting the natural and synthetic systems into a cyborg ecology. A transhuman society established from urgency, the exploited laborers project themselves into an alternate reality, one in which they gain full autonomy by harnessing the power of technology to move into a post-labor future.